Solutions for the checkpoint module 3 solutions. Section 2.5. Here we're asked to, given a graph, to create the graph of f of x plus 1. When we change x into x plus 1, we shift the graph 1 unit to the left. So between -2 and 2, it moves between -3 and +1. And then up to, this graph gets shifted up 2 units, stays at the same coordinates of -3, -1, and it moves up 2. Similar here, we're shifting the graph 1 unit to the left and then down 2. So you see all these points move down at the same x values, but they move down, changing the y value to y minus 2. Here, this particular graph requires, first of all, determining the domain of the function, which is -x plus 1 greater than or equal to 0. When we take the square root or any even root, we can only take from positive or 0. So now I know that the domain is less than or equal to 1, x less than or equal to 1. So the graph of the square root of x, the graph of the square root of -x, it's a reflection with respect to the y-axis. And okay, and then we shift the graph 1 unit to the right. Remember, the domain is less than or equal to 1, so it's right here. In this situation, we have the absolute value of x, first of all, and then x plus 4 again, shift to the left, 4 units to the left. Then this is a reflection with respect to the x-axis, and then up 2. This is the exact correct sequence of steps. Please make sure you understand you cannot add 2 and then come back and flip and so on and so forth. So please understand the base function. We shift it to the left, we reflect, and then up 2. And that's the final graph. This is an additional problem that I wanted to put in writing for you. It's problem 28 on page 294. And this is 1/2 f of x, which is a vertical shrinking of the graph. The x coordinates do not change, but the height for each point is divided by 2. So this was initially a 2, so it comes down to 1. This was initially the height of -2. It will come up, if you want, to -1. This is 66 on 295. Exactly the same thing, same order of transformations in the order of operations, basically. So x squared, shift left 2, then multiply by 2, which is a vertical stretching of the graph, and then reflect, and then up 1. The vertex is -2, 1. Here we had a question on how does this function apply transformations on the square root of x function. And we realize that this is a vertical stretching by a factor of 3 plus 1. And the final step is up 19. We're asked to find f of 48. I plugged it in. The average rate between 0 and 10, please make sure that the average rate has 2 measurement units. One measurement unit coming from the numerator and the other one from the denominator. This is crucial, very important. So the graph is flatter between 50 and 60 months. And as you see, this rate of change, roughly times 5, will give us this rate of change. It's a little bit more, of course. Section 2.6, we're asked to find domain. X cannot be -8 and 10, so we have to write this as the interval notation. Here there are also 2 conditions, x minus 3 greater than or equal to 0, and x cannot be 6. So between 3 and infinity, but I have to exclude 6. Parentheses will exclude 6. Here we're asked to find f plus g, so that's f of x plus g of x, so I just add them, and then subtract them. Make sure you distribute -1. Here just product, and here the ratio cannot have 0 in the denominator, so x cannot equal 5. Now, the domain for the sum, difference, and product is always the same. So this is domain, as I mentioned before, x greater than or equal to 0. And this is all real numbers. When you intersect these two, you get 0 to infinity. But now, so these three have 0 to infinity. This one, however, cannot have 5. So from here, I have to remove 5. So the ratio is the same, except when the ratio is 0. Here we're asked to find f comma g, so f of g of x. So I plug in g in f, and f says 5 times the variable minus 2. 5 times the variable minus 2. Perform the calculations. Determine f comma g of 2. I have it here. I just plugged it in. Now g comma f is the reverse. Is g of f of x. And f of x is this. G says negative variable squared plus 4 times the variable minus 1. This is the variable. I have to square first and then distribute. So I squared first and then I distribute negative 1 and then I combine like terms and I find g comma f of 2. Here plug in 2. This is from the graph. First I have to determine f of negative 1 and then g of 1 because this is 1. This is a function with female and male, so that was the difference. I evaluated for 25, so x equals 0 is 1985, so the difference is 25, so I have to plug in 25. The actual difference from the bar graph is 5 million, so part B, so the difference is an underestimation of 0.2. Section 2.7, when I plug in f of g of x, when I plug in g of x, I have 2 over this minus 5. I simplify, I flip because this is 2 over 1, and I have 2 over x, which is x over 2, and I get x. Similarly, g comma f, I plug in f this time in g, so I have 2 over f, which is this, and plus 5. I have to flip here. I simplify and plus 5 and I get x. Yes, they are inverses of each other. In order to find the inverse of a function that is 1 to 1, I replace f by y. I swap the variables because y becomes x for the inverse function. The y for this function becomes the x for the f inverse. I swap the two and I solve for y, add 1 divided by 3. And this is f inverse, x plus 1 over 3. In the same way as we just did, I determined that the f comma f inverse and f inverse comma f both result in x, so this is the correct inverse function. Here, the same process. I determine the inverse function the same way, and I graph 2 points for this linear function, 0, negative 3, and 3 half 0. When x is 0, I determine y. When y is 0, I determine x, and I get this graph. Every time we graph both the function and the inverse on the same coordinate system, we also have to graph y equals x. Why? Because these two functions are symmetric with respect to this line. So that is very important. Okay, so if the function crosses y equals x in this point, at that same very point, the inverse function will cross. How do I determine these points? I reverse them. So this was 0, negative 3, so now it's negative 3, 0. This point was 3 halves, 0, so now it's 0, 3 halves. And this point has to be part of both. Both domains and range are all real numbers. Here from the graph, g comma f of 0, I have to find, or the table, I have to find g of f of 0. F of 0 was 4, so I got 2. Same thing here, either from the graph or table, I don't remember right now. So g of f of 0, f of 0 was 5, so we plugged it in. This was an additional problem that I wanted to show. So we are asked to find g prime of 7. So I have to set g of x equal to 7 and determine 2, which means g of 2 is 7, which means g inverse of 7 is 2. So that's how we get this. Final section, find the distance formula, x1, y1, x2, y2, and I plug them in and I get this. the midpoint formula, this average of x's and averages of y. Average of x and average of y, so I got this. So we're given the center and the radius. I just have to plug them in. -5 in here and -3 in here. So that's how I get this. And the square root of 5 squared is 5. So finally, we were given an equation of the circle, and we were asked to determine or identify the center, -4, -5, comma, and r is 6. And these two, one is additional. I just wanted to show you more examples. So how do I change this into, if it is a circle, how do I change it? I have to complete the square. And we did that in chapter 2. So x squared plus 8x plus 16 is here. But y squared plus 4y needs a 4 and 4. Okay? So I'm adding 4 to both sides. And y squared plus 4y plus this 4 is this. And 4 is this. So then the center is -4, comma, -2, and the radius is 2. So I showed another example in the same way. X squared plus x plus 1/4, because this is slightly more difficult because the middle coefficient is not divisible by 2. Okay, so I have to add 1/4 to both sides. So these 3 are here, these 3 are here. I move 1/2 to the other side. 1/2 plus 1/4 plus 1/4, this is 1. The center, -1/2, -1/2, and the radius is 1. I hope you find this helpful. Thank you.